Hi, I'm Birgit Leitner and I lead the design efforts at Propel. Just a bit about Propel. We are a woman-owned small business based in Pawtucket, Rhode Island, and our primary business is textile technology development for personal protection. I'm here with my colleague Anjali Kemani, who is an expert on 3D knitting, among other things. Today, we want to show you Propel's smart textile innovations, which were funded under the US Navy Small Business Innovation Research Program. The Navy wanted to know why, despite years of talk, comfortable, wearable, smart garments that could be used to monitor and measure the wearers did not exist. We identified the technology gaps and developed multiple innovations to make user-transparent, washable, wearable smart garments possible. This shirt includes these patent-pending innovations in order to monitor the physiology of the wearer in a garment that looks and feels no different than what the wearer would usually wear next to skin. It is really important that a smart garment not be noticed by the wearer so that the data is not impacted by the change in awareness.
Hello, my name is Anjali Kemani and I'm the co-inventor of the smart textiles innovation that make this shirt possible. We first developed a proprietary electrically enabled yarn that looks, feels, and behaves like a traditional yarn but has the conductive elements needed for transmitting data and power. This e-yarn was developed with 3D knitting in mind, but it could easily be used with more traditional textile manufacturing machinery without any challenges. Our e-yarn is manufacturable at scale. And since our customer is the US Navy, we also made sure to manufacture in the US with US-made inputs. Most importantly, our e-yarn is insulated by construction. It is an e-yarn that is truly wire-like in its electrical properties, but also behaves like a traditional yarn for textiles. And while the shirt uses one version of the e-yarn, we have made multiple versions with differing data and power capabilities.
We coded the initial smart shirt textiles, garment concepts, and prototypes right here in our lab. We designed the garment and knit circuits using the proprietary e-yarns. Here you can see the e-yarn circuit connects the textile heart rate sensors to the data collection module. The wearer's heart rate data is picked up by the sensors and is transmitted by the e-yarn to the data module, where it is collected, processed, and transmitted out wirelessly. We are agnostic as to who supplies the data module, often referred to as the puck. What we have made possible with our innovations is high-quality, consistent data reaching the puck without issue.
Let's look a little closer at the heart rate sensors and how they connect to the e-yarn. You can see here a small patch that covers the e-yarn and the sensor connection point. Underneath this patch is our patent-pending solder-free connector that is so soft and flexible that the wearer won't feel it even if they wear gear on top of it. It's washable too, of course. We can use this connection innovation to connect e-yarns to each other or e-yarns to printed circuit boards, heart sensors, or even printed flexible electronics. This means that there is no limit to the number of sensors that can be attached into a Propel e-yarn circuit. This smart shirt has 2 sensors, but we've built other versions with textile circuits with many more than 2 sensors. We could also design multiple circuits into the same textile structure. For example, you could have a shirt with one circuit on the front and another separate circuit on the back, with each connected to multiple sensors.
Hi, I'm Priya Jyotishi and I work on knitting new concepts using our 3D knitting machine. I'm going to run a short demo of the machine in action. At Propel, we are experts in 3D knitting. We use this method to rapidly develop prototypes and manufacture highly complex smart garments at scale.
The Navy has plans to test our smart shirts. Those plans are currently on hold due to the pandemic, but we expect to move forward as soon as it is feasible. The smart shirt showcases our e-textile innovation, But please don't think the technology is only useful for garments. Our inventions can be used to design e-textile circuits and attach electronic components to sense an array of other measurable conditions. We also have been experimenting with making e-textile cables that look and behave like textiles, but with the electrical function of wire cables.